Okay, so final week of worksheet preparation for the AP exam. Next week is project and 2 videos next week. 1 video this week. But especially for students at home, FRQ6 is only 1 through 5. For you guys in class, I only made copies of what you needed to do, so you don't really have to worry about this. But I didn't go through the trouble of editing them. I just posted them for our online friends. So only 1 through 5 on FRQ6, 1 through 14 on FRQ7. They're not all 14 free response questions, so don't panic. 1 through 4 on FRQ1, and then multiple choice 6 is just the first 2 pages. So don't do all of them, students at home. So I hope you're watching this video, otherwise you won't know which ones to do. But anyway, let's start FRQ6. We'll do 1 and 2, and I will leave the rest for you to do. I will post answers come Tuesday or Wednesday or so. All right, so probably separate sheet of paper. No, not probably. Separate sheet of paper. This thing is due on Monday, May 2nd. Also, let's see, this worksheet. And due Sunday, May 1 is video number 6. Yes, and that algebra thing. Thank you. That algebra review quiz thingy. And again, the grade you get for that is either going to be 0 or 100. A few people have done it and they're sitting on 50 or 75. They're not going to make 50 or 75. They're going to make a 0. So I'm hoping they just pause it and we're going to come back to it and try again. You get 20 tries. They're all Algebra 1, Algebra 2 questions. You're welcome to work together on it because it's meant to review your algebra, some of the basic fraction stuff, exponent stuff, log stuff. So it's not supposed to be hard, but it has all those little mistakes that cost you 2 or 3 questions on the AP exam, and we can't afford to lose 2 or 3 questions on the AP exam. So again, that's due on Sunday. It's in Schoology. It's a Schoology matching thing, drag and drop. It takes a little bit of work. Some of the questions will require you to show some work. I mean, I don't want to see it, but how to phrase that differently. Some of the questions will require you to do some work. Others you can probably just look at and just do understand the properties to get it right. But don't forget it. So I write this at the top, assuming you might write that at the top of your worksheet so that you'll, when we pull this out every day, you'll be reminded the worksheet is due on Monday, the video and Schoology assignment is due on Sunday. All right, number 1. Researchers on a boat are investigating plankton cells in a sea. At a depth of h meters, the density of plankton cells in millions of cells per cubic meter is modeled by P of h 0.2 h squared. I'm glad this is a calculator question. Negative 0.0025 h squared. Okay, for 0 to 30. And this is in, let's say, millions of cells per cubic meter. Okay, so that's the density of cells based on how deep you are. For greater than 30, it's modeled by f of h, but we don't know f of h. So that's kind of a weird thing to give us. So 0 to 30, we know the function that models how dense these cells are. Past 30, there is some function out there that models it, but we don't know what it is. Which, I don't know. That just seems kind of weird. The function f is not given. Find p prime at 25. Okay, well, I think I can do that. Should probably type that into my calculator so I can have the calculator do all the hard work. 0.2 x squared e to the negative 0.0025 x squared. I know I want my window to at least go to 0 to 30. I don't really have an idea of how big the y should be. So I'll go to 100 and see what that looks like. Maybe that's... I'm pretty sure it's all positive because the density of cells, that doesn't seem like something that would be a negative value. There we go. That's not bad for a scale. I'm going to change it to 50. And get a little bit better graph, but okay. Part A, find P prime of 25. So how can I do that? How can I use the calculator to do that? What button do I push? Yeah, second calc or second trace, because there's dy dx. And I can scroll over to 25, or I can just type in 25 to go straight to 25. Again, the AP graders know you're going to do this. They're not expecting you to take a derivative of this thing. I guess you could. It would be the product rule, and you'd have a chain rule, and you'd have a mess, but that's not what they want you to do. They want you to use your calculator. So P prime at 25 is negative 1.179. Using correct units, interpret the meaning of P prime at 25 in the context of this problem. Well, I think it might be better, and this is probably why they didn't phrase it this way, if we wrote that as dp dh, because then we can figure out the units, and maybe the units can help figure out what kind of change is going on here. Well, actually, dp dh, before we even get to units, is change in P, which is cell density, over change in depth. So cell density was millions of cells per meter cubed, and depth is in meters. And you can leave that as the answer. You could change it to millions of cells per meters to the fourth, but I don't think I would do that. I would just say millions of cells per meter cubed per meter. So interpret the meaning of P prime in that context. Okay, so P prime at 25 is, what's probably the magic word I need to use when I'm interpreting a derivative? Rate. So I definitely want to say rate. Is the rate the cell density is changing per meter of depth? Or, yeah, that's one way to say it. There's several ways to say that, but I think that works. I think that would be fine if you wanted to phrase it differently. The rate the cell density is changing No, how else could we phrase this? I'm trying to use the word decreasing because it's negative. The cell density is decreasing. There we go. At a rate of negative 1.179 million cells per meter cubed per meter.
Did you have to specify that it's at 25?
Ooh, you're right. I probably should. At h equals 25 meters. Here's the answers, but let's look at the answers after we do the whole problem. Then we'll see. Make sure that's the right one. Yep, and there's the right answer. Okay, so let's keep going. So, and the answer wasn't hard. The explanation, though, was maybe tricky. Part B. Consider a vertical column of water in the sea with horizontal cross sections of constant area 3 square meters. So I've got some area equals 3 meters squared. It's not necessarily a cylinder, but it doesn't matter. The cross section is 3 meters squared. To the nearest million, how many plankton cells are there in this column of water between h equals 0 and h equals 30? So I want to add up. So if we're adding up all of the cells from 0 to 30, let's see. P of H, I'm also trying to figure out how to get to millions of cells. Per meter cubed. And I want my answer to be millions of cells. Because how many plankton cells are there? So what do I need to multiply by to get to millions of cells? Like I need meter cubed to cancel out. Well, there's part of the answer. Times 3 meters squared. That would get me one of the meters, or 2 of the meters out of there. What's that?
Like the 30.
Yeah, but it's changing, so I can't just multiply. Like if P was constant, I'd multiply by 3 and by 30. That's true. But it's not constant, it's changing. Like it's almost like you'd have to put it this way, I guess. No, it wouldn't be this way. Because there's 0 depth, and as we go deeper, it increases to there, and then it decreases after that. So I think I'm going to, if I integrate by dH, that's another meter, and that will add up basically all of the, instead of adding up all the area slices, I'm adding up all the plankton cell slices. So it's now just a calculator question. Let's see, I can do the integral on the picture, but I need to multiply by 3. So I think I'm just going to go Math 9 and do it this way. 0 to 30. Oops. 3 times P of H is Y1. I don't have to tell the reader that, but what was that, second alpha F4? Nope. Oh, I think it is. The shortcut to the functions is alpha F4? I think it is. It's not on this calculator. So I'm going to go vars and get them that way, which is fine. But yes, alpha F4 usually works. So there's my answer, 1675. To the nearest million, how many plankton cells? So I don't have to worry about the decimals. 1675 million cells. Yes, sir.
What happens to the m squared on the 30?
I mean, that was just the unit. Maybe I shouldn't even have put that there. I could have just put it down here because that's the unit. Just trying to make the units work. Okay, go back and reread the question. To the nearest million, so I rounded right, how many plankton cells are in this column of water? 1675 million cells. Part C. There is a function u such that f is between 0 and u. Remember, f was the function for beyond 30. So we still don't know f, but we know it's less than u. And the integral from 30 to infinity u of h dh is 105. Let's see, that means, let's see, for that column, that's really similar to what we just did. So that has something to do with how many plankton cells there are. The column of water in part B is k meters deep. There we go, where k is greater than 30. So we still have this column of water where the top half had 1675 million cells in it. It's k meters deep, and k is bigger than 30. Write an expression involving one or more integrals that gives the number of plankton cells in the entire column. Okay, so cells equal, we just did this for the first part, so 0 to 30 p of h dh with a 3 on it, plus, this is kind of a tricky one because if you didn't understand part B, you're probably not going to understand part C. But if we understand part B, what am I going to add? What's the next integral going to be? So this tells me the number of cells in that part. How do I get the number of cells in this part? What do I need to add up? 30 to k of what? Of f of h dh, and I still need to multiply by 3. And so, yeah, 0 to 30 is the first 30 meters, 30 to k is the next however many meters there are. So that's one answer. Explain why the number of plankton cells in the column is less than or equal to 2,000 million. Well, I know what this first integral is. We did that one already. That was 1675. I don't know that second integral, but I do know that this integral is less than whatever the u answer was. Less than 105. Does that make sense? Because f is less than u, and that integral up here went to infinity, and we're not going to infinity. So the combination of those two things, f is less than u, we're not going all the way down, so whatever number this is less than 105. Yes? No? So 1675 plus less than 315, if I distribute that 3. equals or is less. So my answer then is less than whatever those add up to be, 1990. So the answer is less than 1990, which is less than 2000. Again, you're going to see some questions on the test that you're like, what are they talking about here? And you're going to have to think through, maybe look at units, think through what they give you to figure out what the heck is going on. Part D. The boat is moving on the surface of the sea. So this is like completely unrelated to the rest of the question, except that they're going to stick a boat up there to try to tie it together as one problem. So the x velocity, 662 sine of 5t, and the y velocity, find the total distance traveled. Okay, total distance is the integral of the absolute value of velocity. Right? Displacement doesn't have the absolute value bars. So that's like a side note. We don't need that here, but that's the difference between those two. Right? Because displacement considers the fact if you ran out and then ran back, you didn't go anywhere. If you run around the track 4 times, your displacement is 0. When we put absolute value bars on there, we knock out all the negatives, so everything adds up. And so, yeah, if you run around the track 4 times, your distance is a mile, even though your displacement is 0. So that's what we're looking for. This is a little bit weird because I have an x velocity and a y velocity. Let's think back to physics here. There's my x velocity. There's my y velocity. How do I figure out what this total velocity is here? We haven't done a problem like this. Physics long ago. Pythagorean theorem. So I guess this overall velocity is the square root of x velocity squared plus y velocity squared. And so the total distance would be 0 to 1. The absolute value of the square root of the x velocity squared plus the y velocity squared dt. Trying to think. Our calculator has a parametric mode. I don't really want to do the parametric mode. I'd rather just stick them in for y1 and y2. Or in this case, y2 and y3, in case I need to go back to that. So y1, 662 sine of 5t. y3, 880 cosine of 6t, 6x. Make sure we're in radians. Whoops, this calculator's in degrees. And then math 9, 0 to 1. You know where the absolute value button is? It's under math, and it does say abs if you find it. Number abs. And if you have an old calculator, it says abs and puts parentheses. If you have a new one, it puts the bars there. Probably not. Oh. Yep, there it is. So this was y2 squared and y3 squared. So vars y2 squared, squared plus vars y3 squared dx. Wonder how long it takes to calculate that. It takes a little bit. There's a lot of thinking going on there. If it takes too long, I get worried. There we go. There's an answer. So total distance traveled is 757. And I'm looking for if it tells me what to round to, but it doesn't. So 3 decimals, 456 meters. I assume everything was meters. Yep. So that was a lot going on in that problem. Although I would say B and C were related, so it would have been really hard to get C without getting B. But D was like completely separate. Like, I mean, yeah, the boat's on top of the water, but that's a completely separate problem that they made up there. All right, here's our answer key with scoring rubric on there. So we got number 1 right. Here's their answer: is the rate the density of plankton cells is changing in millions of cells per meter squared at a depth of 25. So answer, meaning with units. 1675, we got that right. And I promise I didn't look at this beforehand, but they did the unit thing as well to try to make the units make sense. 2 points for that. 3 points for sort of making sense that, we'll see, 1 for the integral, 1 for the compare, 1 for the explanation. Again, I feel like it would be hard to get 2 out of 3. I feel like you'd get 0 or 3 on that one. And then this one's just integral and answer if you understood what total distance was. Absolute value of velocity rather than just velocity. So that would be, to me, that would kind of be a hard one because that's completely made up stuff that they just, can you figure out what's going on? All right, 10 minutes left. We'll see if we can do number 2. Let f be the function defined by this, that thing. And this doesn't say, but because I know that the first 2 are with calculator, if it's number 5, that means this was a no calculator question. Let f be the function defined by that. Find the slope of the line tangent to the graph. Okay, I like these questions, right? I know how to find the slope of a tangent line. Famous last words. Some confidence here. I need f prime at 3. Find the slope of the tangent line. I think I would like to rewrite f as 3 times all of that stuff to the negative 1. Because I think that's going to make me, or allow me to find a derivative a lot easier. So f prime, bring down the negative, decrease the power by 1. Is that my answer? No. Why is that not my answer? Chain rule. So times 4x minus 7. So if I want to clean that up a little bit, negative 3 times 4x minus 7 over 2x squared minus 7x plus 5 squared. So f prime at 3 would be the slope of the tangent line. I'm sensing a safe stop coming up soon. 4 times 3 is 12. 2 times 3 squared minus 7 times 3 plus 5 all squared. And I'm done. Right? I haven't read the rest of the problem. Maybe I need an answer for that, but I'm good for part A. Part B. Find the x-coordinate of each critical point. Critical point, that's where f prime equals 0 or undefined. In the interval 1 to 2.5. Classify each critical point as a relative min, relative max, or neither. So I'm already thinking number line, increasing, decreasing. Maybe second derivative, but I hope not, because second derivative of that would be ugly. So hopefully I can get by with a first derivative number line. So I need to know where this thing is equal to 0 or undefined. So where is the first derivative equals 0 or undefined? Well, 0 would be if the top is 0, so that's the easy one. And, it gave me an interval. That might be useful because maybe I can throw some of these out. On 1 to 2.5, and actually not including 1 and not including 2.5. So 7/4. Yep, 7/4 counts. Counts, it's on the interval. Undefined would be where the bottom is 0. Since this is a no calculator question, I'm hoping this thing factors. Let's see, 5 and 1 both need to be negative. If I do it that way, I get -5, -2 makes -7. Okay, they did me a favor here. X equals 5/2 and x equals 1. What about x equals 5/2 and x equals 1? They're not on the interval, so not on interval. So I don't have to worry about them. So my only concern is 7/4. And I need to check something less than 7/4 and more than 7/4. More than 7/4 I can check 2. Less than 7/4. Why should I be careful about picking 1? Yeah, it says like 1's not in the interval. That's kind of annoying because I don't have any good options. Less than 7/4 but bigger than 1. 5/4, 6/4. That's kind of my only choices. I'm going to go with 5/4. So f prime at 5/4. So back up here. -3. 4 times 5/4. Okay, that's not as bad as I thought it would be. What about the bottom? Is it going to be positive or negative? They're throwing me all kinds of bones here. That bottom, whatever it is squared. So it's positive, so I don't have to worry about that one. So the top is, 4's cancel. 5 minus 7 is negative times negative is positive. So f prime is positive. That means f is increasing. And then if I plug in 2, -3 times 8 minus 7 is 1. I get negative over positive, which is negative. That's for f prime, which means f is decreasing. So what does that mean at 7/4? Is a relative max And what's sort of the universal reason for, not universal because it could be a second derivative test, but what's positive to negative? F prime. I think that's all they asked for on that. Okay, we're almost out of time, but that's good news because C and D we did not do. These are BC topics. We don't do intervals that go to infinity. And we definitely didn't do series, converges, or diverges. That's BC stuff. So you can throw out part C and D. And then also on number 5 on the back, you can, especially without a calculator, you can throw out part C of number 5 because that's a BC topic. But the rest, I think you could handle. All right, so worksheets, videos, algebra review, a lot of stuff going on this week. I'll say it every day that we start and end this week so that hopefully you do it all